So we left each other with the description of data types in MATLAB, and we saw the numeric and logical data and how create these two classes. Now we deal with strings, that is data containing text. For example, let me clear all the workspace. So if I write x is equal to Marco with just one quote, okay, and then we do x plus 1, okay, what do you expect? Maybe you expect Marco 1, something like that. And this is what you get. So vector, which has five numbers because there are 5 letters. And why 78? 78 because the ASCII code of capital M is 77. So if you have something which is created with single quotes, then MATLAB stores internally capital M as 77, then A as 97, because 77 is the ASCII code of capital M. On the other end, you see that 97 is the ASCII code of A, right? Okay, so if you have therefore Marco plus 1, because Marco plus 0 is this, therefore Marco plus 1 is add 1 to each element, and therefore the char of Marco plus 1 will be what? The char. So capital M add once, so becomes N, A becomes B, and then so shifts by one letter, right? So you see NBSDP. So C gets D and O becomes P, right? So plus 3, you shift by 3, right? So, and then similarly, as we did the sequence from 4 to 10, now we have the sequence, for example, for 70 to 80, the char of these are the corresponding letters. Similarly, the sequence from A to Z, you see, right? The sequence with step 2, you see, A with step 2, writing A with single quotes or the corresponding number is the same, the corresponding ASCII number, right? And similarly, the sequence from A to lowercase z, these are, you see, all the ASCII codes. And so in programming, so the curly brackets, open curly brackets is 1, alt 1 to 3, 123. So the char of 123, this is the open curly brackets. The char of 123 to 26, therefore 23 is the curly brackets, 24 is the pipe, 125 is the close curly brackets, and 126 is the tilde, right? So this is depending on your keyboard, so remember that because you are going to use the curly brackets quite a lot. Okay, now on the other end, therefore there is a big difference between Marco written in this way or Marco written with double quotes, okay? Written with double quotes, Marco plus 0 is what you expect, is Marco 0, right? So the size of Marco 0, the size, the number of elements is one column, one row, and one column. On the other end, the size of Marco here, what is the size of Marco? Is 1 times 5, 1 row and 5 columns. So you talk about character vector if Marco is written with just one quote, right? Okay, the other thing was the string array. So Marco, and then here you have Paul, and this is X. So the size, okay, you see that the size is 1 times 2, right? On the other end, if I do this thing here, let me see. If I do these things here, it works. Here you concatenate 1 by 5 and 1 by 4, so it does not work. Okay? Dimensions are not consistent because 1 times 5 and 1 times 4 you cannot. But this one works if I have a space. Yes, 1 times 5, 1 times 5 is 2 times 5, right? You see there is a space. Therefore, if I take the second column of X, what do I get? The second column. AA, clearly AA, right. Exactly. And the second row here is this one, right, Paul with the space. X2 and I don't see anything because it is the space, right? You see the space, which is a character, right? So keep in mind this difference between this char and string, and they have a different symbol when they are seen in here in the variable space, in the variable editor. So str, and this is a character, ch. 2 times 5 character. On the other end, xx is equal to whatever, and this is a string, str. Now, all these have been done, and now the cell. Now we go back to the first row. Cell is a container, so cell contains all types of data. For example, you see this in this cell here their cells are created with curly brackets, and this is a cell of size 2 times 3. Here it contains a scalar, a vector, a number, then a character vector, a matrix, or whatever. Inside the cell you can put whatever you like, right? So let us see with the copilot. The copilot. Let me go to the copilot, create a cell of size 2 times 5 with different variable types. See? Okay. See, let us see the code. Here is, you see how it has created it. First row with various types, second word with various types. Let us run now this file. See, let us run now without saving the file, evaluate selection in common window. Okay, this is the cell. Now suppose that I want to extract this element. Okay, so this is a cell. It contains things that have a different dimension. Therefore, C23 is this one. C23, you understand the syntax, the elements which is second row and third column, C23. This C23, this is a cell, C23. See. Okay. Now, if I use the round brackets, it extracts, but it remains a cell. On the other end, if I use the curly brackets, I extract the content, what is inside, right? So, it is important to understand the difference between using parentheses, returns a cell, using curly braces, access the contents, right? So this is the extraction of this thing. Note that certain operations do not work with cell because they are different. There are different types. Therefore, if you have this C plus 10 does not work. Plus, minus, do not mean anything because they are containers which have objects of different types. But if you have the cell array of characters, note that you have characters which have different length. Marco, Luca, Paolo had a different name with different length. They can be put together in a cell. Yes, because the cell can have heterogeneous element. Now, let us see, create a cell array of character vectors of size 2 times, okay, let us do something bigger, of size 3 times 5. At least the copilot is very helpful because you see how the elements that are created by the machine. Row 1, call 1, row 1, call 2. No, just write random, yes, but write random names inside. Let us see. I don't want to have row 3, column 2. Okay, very well. Very well. Now it is understood. Okay, this is C. And now we have this C. Now, C, therefore, C13 is what? Is a cell, right? C13 is a char, and C13 plus 1, and let us see, the char of C13 in curly brackets plus 1 is what? Capital C becomes capital D because it's plus 1, right? You see, you have added 1, right? Okay. You understand this code, do you? So you have extracted the element which is in row 1, column 3, using curly bracket, so it is a character vector. If it is a character vector, then you add 1 to each element, and so this does the job. Now, let us see. We want to see all elements of C which are equal to Nina. C is equal to Nina. It works. You see all the logical things that we have seen before. So you see, Nina is the only one which gives you a true. all the others are false, right? Then, therefore, curly brackets are admitted to access the content, parentheses, round parentheses are admitted as an indexing operator, concatenation is admitted, something like that is admitted, right? Then what you have, therefore operator equal to a string works just if all elements of the cell are character vectors. You see, these things work. On the other end, if C, for example, if C13, for example, is equal to 2, so you see that one element is not a character vector. Then C is equal to Nina. Works? Does not work. Because cell must be a cell array of character vectors. If one of them is not a character vector, does not work. But it says all the things are very easy once you know. If you don't know, then may seem obscure. Then there are functions that operate on each element of the cell. For example, it is quite advanced, but here it says that each element of the cell is raised to the square. But we are going to see it on a later stage. Of course, from cell array of character vectors, you can change to string array in the sense that if you have this C, if you have this C here, then you do string C, and then you transform it into a string array. Okay? And with the string array, you can do the same with string array. C is equal to David, and is of course 1 in correspondence of David. Now let us go. So string array around the plus. Now let us see the string array. For example, string array, so the string C, and then we call this D. So D is a string array. So if I say D1 plus D2 is what? For example, here I say D1 plus D2 concatenates column 1 with column 2, right? So, for example, if I say this and then these things plus, and then adds this symbol. It's like the matrix operation when you add something, which is plus means concatenation. Plus for numbers means plus. Plus for strings means concatenation. Now the struct. The struct contains labeled fields of different types. Let us see. For example, create a struct using different field. The name of the structure must be student. Find appropriate fields. Yes, fields. Right. It has created something even more elaborate that I wanted to have, because it creates an array of structure. So each structure, for example, if this structure, so for example, it is x is equal to this struct, so x, you see. So therefore, a structure is a collection of fields, it's a container. And this container can have different fields. These different fields can be of different type. For example, x dot, I don't know, record is equal to an honest of 3 times 1. So to each field, and this field is with the dot notation, right? You can add any field, and any field can be of different type and different size dimension, right? So then this is x. In order to find, for example, x major, and then gives mathematics, x record, and record, right, and then this matrix of ones. So you create the structure in two possible ways. This is the first way. The first way where, let us see, the first way where you put struct, and then this is so-called name value. This is the name of the field, and then this is what the field contains. This is the name of the field, what the field contains. For example, x here is a structure with a series of fields, x. For example, x dot name is Alice, x dot age is 20, right? Or, for example, you can say the other option is x is equal to a new structure, struct, and then you add the fields later on. So x dot name, that does not exist, but you create x dot name is equal to Alice. Alice, okay. X dot surname, and then you create surname Alice, surname XXX, maybe okay, with characters or whatever. Then X has these two fields. You can remove a particular fields, or you can understand what are the name of the fields, then field names, the name of the fields, name and surname. So these are different containers, the struct. So we have seen the cell, we have seen the struct, we have seen the numerical, logical, categorical, char, string, and now it is time. So this is going to repeat what we saw before. Mode 1 to create the structure. Create an empty structure and then add the fields. Mode 2, all in one row. Structure and then name value. Right. Then you can remove a field of a structure, for example. But there is the auto-completion, so remove field is RM field. Let us see if there is still in memory. This is a cell array. We had created a structure X. Let us see this X. So this is the structure X. RM field X, and then which field would you like to remove? I'd like to remove age, and that's it. Okay. You see previous structure and the current structure. Of course, you say X is equal to the one that it was before, but with the age field removed. Right? Therefore, these fields can be everything. Now, the table. The table is an array with names for each column. Each column can have different data types. So, first, so you see now we are seeing these two, and now we see the table. I'm sure that this is very basic for those who have already seen MATLAB several times, but be patient, right? We will do something much more difficult in the coming weeks and in the coming days. So let us start, for example, with table creation. So this exercise says, okay, I have this matrix which contains these 4 numbers. I have to create the corresponding table. The table has row names and column names. For example, let me see if I have, or let me generate, let us start with this magic 5. So this is X. Suppose that I want that this becomes a table, and then with particular column names, my column names are, I don't know, whatever. Suppose that these are 5 Italian regions, and these are 5 variables. Let us see what the Copilot does. Where is the yes? Okay. From array X. You cannot. Okay. Thank you for telling me. Probably you have those who see on YouTube could see, but you could not see because it was stuck to the PowerPoint presentation. So here what I did, I created this matrix X. Matrix X must become a table with row names and column names. Okay, and so I ask Copilot, from array X, create a table. Create a table. The name of the rows are, let's see, 5 Italian regions. Italian regions. The name of the columns are 5 brands. Let us see, because everything, it is always a mystery what Copilot can do. Incredible. Incredible. Then he has given me the 5 Italian names. Yes. Okay, let us. Yes, you see, now, you see that it has created, this is C, no, this was our magic 5, This was our magic 5, not random variable for define the row names, Italian region. You see this cell array of characters, you see these row names. Now you see these column names. Now, with these numbers, these row names, and these column names, you wanted to create the table. Okay? So, you do array to table, auto-completion. Then what? Array to table, then I want to create the array to table of my array to table. I want to create array to table of what? The input matrix, which is C. Then I want to have row names. What are the row names? The row names are these row names. and then I want to create the variable names, which are the column names, and that's it. You see how everything is extremely easy in MATLAB. Tell me what is the difficulty? None. Really none. And so this is C table. Run. No, dot save, well, maybe save, yes. Save with TMP, if I don't know the name, okay. And this is now I table. Now, if I do, the table is C table, then second column, what do I get? The second column, but in table format. On the other end, if I put the curly brackets, what do I get? Just, as we have seen, just the numbers. With the curly brackets, you access the content, right? So, then C table C, and then end to the element which is the final row, and then second column, C table end to, with the curly brackets. On the other end, with with the round brackets, then it still remains a table, right? Therefore, if I want to have the profile C, it is C table of, you see that it tells me, it knows the names. C table of Lombardia, and this is the profile of Lombardia, right? Why don't we use? You can use both. Well, in the sense that these row names could be also something like that. Row names 1, for example. Could be also a string array. It's the same thing. Because, you know, this is a cell, so the elements of the cell must be surrounded by curly brackets. This is a string array, and therefore square brackets. Because you enclose numbers, 2, 5, a vector is square brackets. And so string array is the same thing. Therefore, now, yes, thank you for the questions, because indeed it is crucial. So you see, to concatenate is always square brackets, right? On the other end, this concatenates this C with another C, which is a cell, with another cell, you see, and then concatenate with on the other end, in order to create a cell. You create the cell with using this curly bracket operator. So the curly bracket operator is used, 1, to create the cell, 2, to extract a particular element of cell, or to extract a particular element inside the table in order to access this content. Thank you for your question, because this gave me the possibility of being more precise. Thank you very much. Just 0.5 points. Yes, I do remember, yes, very good question, right, which is in fact is crucial. Which parentheses do I have to use? And here the row names can be row names here, but also row names 1. This one. Here there is a mistake. Here you see, because I started with these parentheses and I closed with the curly brackets. You see the power of MATLAB, that it immediately tells you what is the mistake. So, but what is nice, when I do array, for example, let me run all this. And then I do array to table, and then what input matrix C, and then row names, and then row names. Here it tells you the elements that can go here. You see how intelligent it is. It knows that here you can have either a cell, and then you see the string, or either another cell, or either a vector, a string array, right? So these are just these three are three possible candidates. In this case, is row names 1 or row names the same thing, and then these things creates. Without, you see the columns C1, C2, C3, C5, because the array is called C, and so these are the names that it gives. Right. If the array was called XX, then as possible candidates, then you have XX1, XX2, XX3. Right. On the other end, no, my variable names, automatic variable names, are column names, right? And so this is the thing, right? That everything is so this was how to create the table from the array. Now suppose that you have an external file. Suppose that you have this file which is called firm, so that you create a new live script, and then you want to import this file. Okay? If you want to import this file, what would you write if you have to import? Imp. Okay, imp to import the data, right? This is what you write automatically. And here, what do you choose? You have to import the data from a file. Yes. You know, and this is the power of MATLAB. Automatically creates a graphical user interface that lets you input the file. Select the file, browse, firm.open, okay. Now we see maybe the output of this code, and here is the output, the preview of the output. Then sheet, because if the Excel file has different sheets, so you select which sheets, and then type which is the output. You want to have a cell array, you want to have column vectors, you want to have column vectors, you see. This is the preview of the output, that every column is imported as a different column vector. No, I want to have a table as the output. You see, it is absolutely extremely easy. Then data as variable names, yes. Data as variable names, yes. Otherwise, no, it's not the code, surname, name. They are not. They are variable names, what is in the first row of this Excel file. Therefore, data has variable names. And then show code. Show code, and then this gives you the code that is automatically generated, which is quite cumbersome. Indeed, what you really need is read table, nothing else. Then all the other is here controls. Here you see the sheet, the data range, just in case you want to open a different data, import a different data range. Then the which type, variable names, variable types, how they are loaded, if they are loaded as double, categorical, and so on and so forth. But certainly, let us do hide code, and let us do maybe code only, controls only, code only. You see that you see just the code. Now let us maybe delete all this, and let us do with read.table. Okay, so read the table, and then file name. Tell me the name of the file. File name is firm. Then tell me what is the sheet. Sheet then automatically gives you the name of the sheets. If there are different sheets, it proposes here the different sheet names, data, and then here the range. If you do not specify the range, it tries to import all that it finds. For example, let us do maybe something personalized, range, not file type, but range, and this is the Excel, for example, A1, C5, and then assign it to X. And this is what he has imported of this file. Then without the range, so that it imports all the records. You see, all the records. Now, one important thing is the first column is a row name or not. The first column. In this case, the table has 10 columns. And then I have an option, which is read row names, right, correct, read row names, which is either true or false. If read row names is true, the table is imported as with 9 columns. The first column is considered as a row name. So let us run this one. So now X is 9 columns, right? So this is considered. Let us open now this in the variable editor. X, this is my table with the preview of the column. So for example, X, and then the name of a particular row gives you this profile of a particular row. Suppose that I have to extract maybe P0 205 and P0 227. This instruction works. Suppose that I have to extract these two rows, but I have to extract this vector. What do I have to put? Right, good. Let us see. No, invalid use of operator. It doesn't have the square bracket. Right. Okay. Then, suppose I have to extract, for example, education. Then X, here there are the names. Therefore, education, you see. Take education. On the other hand, suppose that I have to extract the content, x dot, you see, education, like for the content. For example, let us see for x as this variable which is called wage. So let us see the preview of x. X as wage. So X here wage. For example, the first 5 rows is a table, right? X with the curly brackets is what? Just the 5 numbers, okay? Another possibility is X dot the name of the variable and then the first 5 rows, which is exactly the same. You see? Curly brackets or dot notation, same thing, right? Or the other possibility of importing a file is right click and then you go to import data. Gives you an import tool, and then here import selection, import data, and the same thing, right? Okay, so we have seen the tables and how to access the open or create a table using different options. Okay, next time we will do some table extraction, and then we will do the sum of table and operations with tables. So we see again, if you like, tomorrow in the computing labs. You will please come with, if you come with your portable, come with MATLAB already installed, right? You don't need to come with your portable, but if you come with your portable, come with all the installation already done. In the meanwhile, this class will be put on YouTube, okay? Thank you for your time.